Okay, so in this next topic, let's take the same equations that we talked about in the previous video. So that's 5x equals 10, and then it was 3x plus 6 equals 15. We're going to use both of those equations in this next section, but I'm going to present it to you in a bit of a more tangible, visual method. So take a look at this little slideshow I have for you. We have a nice little outline of a scale. That gray thing in the back is meant to be a scale. So a scale, of course, works by it holds its balance as long as the stuff that's on one side of the scale weighs the same amount as the stuff on the other side of the scale. Now, it doesn't have to be exactly the same thing. Like, for instance, if I were to have a scale, so I have my two sides, and I put a 5-pound bag of potatoes on this side and a 5-pound bag of potatoes on this side, it should be equal in theory, right? If we have exactly two exactly 5-pound bags, they should be nice and level. But I could also mix it up. Like, I could put a number of potatoes on this side and a number of, I don't know, kiwis, because they're kind of different than a potato, on this side. Now, I have to have a lot more kiwis than potatoes to make this thing stay equal. Because if I just had like 5 potatoes and 5 kiwis, the scale would be all off balance. But if I eventually, maybe I'd have to cut a kiwi into pieces to get it to be exact, but eventually I could have them weighing exactly the same amount. So that's kind of what I want you to be picturing when we go back to this slideshow. So take a look at it again. We have on the left-hand side 5 presents. We don't know what they are. We don't know what's inside of them. We don't even know how much they weigh, but there are 5 of them, and I'm going to tell you for the sake of argument here that they are exactly the same. Whatever they are, they're exactly the same. They weigh the same, they look the same, they take up the same amount of space. They're 5 of the same presents. On the right side of the scale, we have, I want you to think of each of those little red circles as if they were a 1-pound weight. So we have a total, if you count it up, we have a total of 10 1-pound weights. And as it turns out, when we have 10 pounds on the right side of the scale, it makes the scale balance perfectly with our 5 presents. Okay, that's our situation. The question that I'm going to give to you is, how much does each present weigh? If 5 presents weighs the same as 10 pounds, how much does each present weigh? Now, not the toughest question I could ask you, but let's think about how we would solve this. I would say, okay, each of the 5 presents are the same, so let's line them up over here down the left side. And we have 1, 2, 3, 4, 5 presents. And then I'm going to take my 10 1-pound weights and I'm going to kind of line them up equally. So each, as it turns out, each present is going to have 2 1-pound weights. One present is 2 1-pounds, one present, 2 1-pounds, one present, 2 1-pounds, one present, 2 1-pounds. I know this is redundant. One present, 2 1-pounds. Okay, they each get the same amount of weight, kind of divided out for each present. And when we look at it that way, we can easily say, hey, I know how much each present weighs. Each present has to weigh 2 pounds, because then I have 2, 4, 6, 8, 10 pounds total when I put the 5 presents on the scale. So what have we just done? Well, we've actually solved the same equation that we solved earlier. Well, we wrote it as 5x equals 10. In this case, I put 5p for presents. So 5p or 5x equals 10. We basically divided each side into 5 groups, 5 presents, 5 groups of weights, and we found out that each present is equal to 2 pounds. I want you to think how that compares to the way that we solved the problem symbolically. In fact, let's do that right now. Let me go back to our, hold on one second while I pull it up for us. Right here on the left side, we see We had 5x equals 10, and I said in order to get x by itself, we need to divide each side by 5. Well, that's exactly the same thing as taking our 5 presents and dividing them into 5 groups. 1, 2, 3, 4, 5. And then dividing our 10 weights into groups, which gives us 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So as you can see, we basically just did the same problem. Here it was actually a little bit simpler. That's generally the point when we do something symbolically. It makes our life a little bit easier. But we did the same thing. 5x equals 10 gives us a solution of x equals 2. In the same way that, let me pull up our little slideshow here again for you. In the same way that we should with the presents, actually let me go up one. The 5 presents equals 10 pounds or 2 pounds per present. Okay, let's look at this with the second example that we had, which is, let me pull up our other example. We solved the equation 3c plus 6 equals 15, and eventually we showed that c equals 3. Now, let's see how that relates to a visual situation. Okay, here I have 3 suitcases on the left side of the scale. And on the right side of the scale, I have 15 1-pound weights. But to make this a little bit more complicated than the last section, I also have 6 1-pound weights on the left-hand side. So I've got 3 suitcases and 6 1-pound weights, and then on the other side I have 15 1-pound weights. Now, at this point, they weigh exactly the same, which is nice and convenient that the 3 suitcases and the 6 pounds is the same as 15 pounds. However, if I were to try right now to sort out the 1-pound weights for each suitcase, I would end up I would have all of this leftover stuff right here. Like, what do I do with that? So I have an idea. If it causes us a problem, why don't we get rid of it? Right? The 6 pounds over on the left is just making life more complicated. So let's get rid of them. But remember, there's one trick. We have to keep both sides of the balance equal, of the scale balanced, or equal weights. So if I'm going to just take away the 6 pounds on the left, I really need to take away 6 pounds on the right. They need to be, the amount that I take away from the left and the amount I take away from the right needs to be equal. That's the only way I'm going to keep it balanced. Does that sound like a plan? Let's see what happens. Take them away. It stays balanced. And now this looks so much easier. On the left side, I only have my 3 suitcases. On the right side, I have 9, if you count up, I have 9 1-pound weights. So 3 suitcases is the same as, or it's equal to, 9 pounds. So what's the weight of each suitcase? Well, we can sort it out the same way that we did last time. Each suitcase gets 3 pounds, because that adds up to 9. So I figure out that one suitcase is 3 pounds. What does that look like symbolically? Well, we start out with 3c plus 6 equals 15. Again, to make life simpler, we get rid of the plus 6, right? Earlier I said when you're unwrapping a present, like a present within a present within a present, you want to take the stuff, you want to unwrap the biggest present first. We want to take the stuff that's on the outside, that's further away from the nice, beautiful ring at the center. You want to take that away first. And the plus 6 is that number. The other way we can think about it is on the balance. We know what 6 is. 6 is 6 pounds. So let's just get rid of it to make life easier. Get rid of the 6 pounds on the left, get rid of the 6 pounds on the right. And when we do that, we're left with just our 3 suitcases and 9 pounds on the right. In other words, we subtracted 6 from both sides. And then we decided to basically partition them into groups. Each suitcase now has to be worth 3 pounds. And again, mathematically speaking, what we did is we divide the left and the right by 3. Let's take a second to think about that. and then we're going to move on to solving some examples that are maybe a little more complex than this, but using the same principles symbolically.